we just finished around the world. We just reviewed how to solve direct and how to solve inverse. You guys are feeling pretty good about that. I will tell you, you're more likely to see inverse, less likely to see direct on the final exam, but you are going to see both on my test at the end of the week. All right, we want to talk about how do you identify direct and inverse from a table. So I've got 3 tables. Everybody see table Roman numeral 1, table Roman numeral 2, and table Roman numeral 3. Y'all got your notes, right? Everybody's got the orange sheet up front. Okay, what we're going to do is we're going to check the X's. So if I go jump down here to table 1, if I go across the table, 25 to 50 to 60 to 100 to 150, are they going up or are they going down? Up. So I'm going to put a little up arrow on my paper. Put a little up arrow on your paper. Now take a look at the Y's. 8 to 4 to 3.33 to 2 to 1.33. Those went down. Now, which relationship most likely has one going up and one going down? Direct or inverse? Inverse. So we're actually going to answer question A or item B and item C for all 3 tables. Okay? So for Roman numeral 1 table, that's what I meant for it to be. We think question A, we think it's inverse. Now just because that's our first idea, you have to check it. Here's how you check it. What does it say at the top? How to tell for sure? Do what? Check the constant. How do you check the constant if it's direct or inverse? So y is equal to k over x. So we already know y is up when x is down, so that's definitely inverse. How would you get k by itself? Multiply both sides by x. So k would equal what? X times y. Well, just so happens I have an x and a y. I'm going to x times y. What's 25 times 8? 200. It's like 8 quarters, right? It would be 200 cents or $2. What's 50 times 4? You have to check multiple x's and y combinations. That's also what? 200. What's 100 times 2? Also 200. So far it's looking really good. I do think because of the decimal, I do think it's going to give you like 199 point something. Would you grab your calculator and do 60 times 3.33? What'd you get for 60 times 3.33? Okay, 199.8. And guys, that's because they've rounded off the fraction. So we're going to say that's still good enough to be 200 is my constant. In other words, this is pretty consistent across the numbers, that the constant stays the same. So part B says find the constant of proportionality k. We just found out k was what number? 200. Part C, write the equation. Now we did that in class yesterday. If I'm writing an inverse equation, do I need a bar in it? Yes. So I need a y in it, and I need a bar, and x goes on the bottom. Remember, y is on top when x is on what? The bottom. That's what makes it inverse. Now, what number goes on top? 200. So I just answered all parts, A part, B part, and C part, just by looking at values in a table. I don't have a graph. Okay, how about table 2? How about table 2? Just table 2, check your x's. What's going on with my x's? Go across your table. 10, 15, 25, 40, 100. They're going up. 6, 9, 15, 24, 60. What are my y's doing? Going up. Okay, which relationship is one goes up, the other goes up? Direct, right? So for table 2, it's looking like it's direct. Now, it may not be direct, but it looks like direct. So how do we check for sure? Check the constant. Okay, let's just review real fast. What is the equation for direct? Y equals, do I need a bar if it's direct? No. So it's going to have constant k in front of x. How do you solve for constant k? I would have to divide by x. So it would be constant k is y number on top and what? X number at the bottom. Did Miss Jessup have that stuff up here? Yep. For quick and easy reference, I've got direct and inverse main ideas. Memorize this one. Memorize this other one. Don't necessarily need to memorize the constant. Okay, you can always solve for those. So I need a y number over an x number. I'll give you a hint. It is not 10 over 6. What should it be? It should be 6 over 10. So if I check these two numbers, the 6 is the y. Divide that out. Who's got calculator? What's 6 divided by 10? That's 0.6. Okay. Let's check 9 divided by 15. 9 goes on top. Y number goes on top. 0.6. This one's looking good too. As long as we get a consistent constant, we're going to say, yep, it really, all of the numbers make out to be direct. Everybody good? Are we getting 6? Okay, I know the last one, 60 divided by 100. I know that one's still 0.6. So, part B, I think we can actually say that constant is 0.6. What does my equation look like? Do I need a bar to write this equation? No. This is a direct equation, so it's just going to be on one line, y on one side, x on the other, and what goes in front? 0.6. Did everybody get that equation written? The way you do inverse and the way you do direct are different. All right. I'm going to let you give it a shot. I'm going to let you finish table 3. And I want you to go to the bottom of your sheet, and there's 3 tables. I'll give you a hint. There's at least one neither that's going to show up. Okay? It might be B. It might not be. Okay? So go ahead, give it a try, check it out, see if you can do, I want you to do all 3 parts. See if you think it's direct or inverse to begin. To confirm whether it's direct or inverse, check the constant. And then, if it is direct or inverse, write an equation. Okay, so we're going to pause. So we're going to finish table 3 and do A, B, and C. Everybody good? Just a little bit of class practice. All right, hopefully you pause the video, and we will now go over the answers. Table 3, it's inverse, constant's 48, y equals 48 over x. And A, B, and C, B was actually a tricky example. It turned out to have a negative constant, and that means that the graph would have flipped. But if you did check multiplying x and y, you do get negative 12 for a consistent constant. What makes C be a neither is the fact that even though it looked like it was inverse, we checked the constant. We got a really big constant for the first row and a much smaller constant for the second row. So, all right, that is our direct versus inverse. All right, I'd like to go ahead and talk to you a little bit about powers. Devices, out of sight. Okay, here we go. I want to talk to you about powers, because in the real world, if you recognize the first equation, anybody recognize A equals pi times r squared? What is that? It's actually the area of a circle. Okay? So, what I'd like to do is talk to you. Here's what happens. If you check it out and look, where is the r positioned? Is it on top or bottom? R is on the top of a fraction. If I put 1 under it, where is the A? He's on top. What kind of relationship is it that when one's on top, the other one's on top? It's direct. Now, this one is still direct, but it's direct with a power. R is to the second power. What we did today and what we practiced yesterday, I had no powers. It was just this is related to this, and nothing was squared. Now, here's all I need you to know, okay? What happens is, if the radius of a circle gets bigger, okay? So let's just say we have a short radius, and this is just a real easy 1. Here's the circle. The area is the space inside the circle, right? So I have a small amount of space. What happens, though, if I double the radius and make a circle with a bigger middle? Does it make a bigger circle? Does it make a bigger circle? Yes. Okay. All right. I want to calculate this. Who's got calculators to help me? Okay. Let's calculate the first circle. Area is pi times the radius of 1 squared. What's 1 times 1? Okay, what's 1 times about 3.4? 3.14. So that has an area of about 3.14, right? Or this is actually the way that you would see it in an advanced class. They would say 1 times the pi number, because pi happens to be one of those numbers that's a decimal that doesn't end or repeat. Everybody remember that? So it's actually more accurate to say 1 times the pi number, or 3.14 if you worked it out. Now let's do the area of the second circle. Well, of equations that have powers in them. Okay. Area of this one is pi, and this time the radius is what? 2, and we're going to square it. What's 2 to the second power? 4. So that's actually 4 times pi, or 4 times the pi area. Now, grab your calculator. What's 4 times 3.14? So it's approximately 12 point what? 56. Okay, it depends on whether you use the pi key or whether you type in 3.14. Now, here's what I want you to see. Do you see the area went from 3.14 to 12.56? Okay, let me ask you a question. Did the radius get bigger? Yes. The radius went from 1 to 2. The radius doubled. Everybody good? Now, normally, if I was talking about an everyday basic direct equation, let's think about pay in hours. Let's say you go to work babysitting, you get paid $10 an hour. Okay? So, okay, $10 an hour. Let's say that you work 2 hours. How much money do you make if babysitting a kid for 2 hours? $20. What happens if the call comes and she says, hey, I need you to babysit double the hours today? How much pay would you expect to make? Double the pay. So in most normal direct equations, if 1 goes up by power of 2, or multiplies times 2, the pay would multiply times 2. But take a look at our area. My radius got how much bigger? It went from 1 to 2. How much? My radius doubled. How much did my area change? It went from 3.14 to almost what? 12.56. It went from 1 times pi to 4 times pi. In other words, my radius got doubled, but my area got 4 times bigger. Here's the one thing I need you to remember about powers. It can still be direct. As one goes up, the other one goes up. But as one goes up, the other one goes up faster. Further and faster. Still direct. If one goes up, the other one goes up, that's direct. But if one goes up doubled and the other one goes up doubled, that's just normal. No powers. But if one goes up and the other one has a power, if you start squaring numbers, look, what happens if I square 2? 4. What happens if I square 3? Then it goes to 16 squared, 4 squared, 5 squared is 25, 36. Do the numbers get bigger faster? Yeah. So if you include powers, I don't know, I said 4 squared is 16 and 5 squared is 25. I was trying to get too fast and I said the wrong thing. My point is this. When you have a formula with a power, if one variable goes up, the other one goes up too, but it goes up faster rate. Because when you square something, it makes it grow faster. Is everybody good with that? Okay. That was the first point I want to get across. We're going to stop with this. Okay. I'd like you to go with me to the next one where it says combined or joint variation. We are. It's going to be short. Okay. For the first time, we're going to talk about equations that might have 2 or more variables, or actually more than 2. Is anybody familiar with the volume of a box being length times what? Width times what? Height. In other words, there's actually 1, 2, 3, 4 total things that I'm talking about. I don't even have a number, but I have 4 different variables. I would like to consider hide the W and the H. Pretend they're not there. How is L and V vary? If the length of the box got bigger, what would happen to the volume of the box? It'd get bigger too. everybody good with that? So, okay, now I want you to pretend the L and the H aren't there, and let's talk about W. What if the width of the box got bigger? How would the volume change? It'd get bigger too. Okay, one more time. I want you to ignore the L and the W. This time let's only consider, what if the height of the box got bigger? How would, does everybody understand that all three things are all directly related to what? Volume. For the first time today, you may actually hear yourself say, and. The volume of the box is directly related to length and directly related to width and directly related to height. All three are directly related. Okay, this word right here is what we can do when you have multiple things that are all multiplied and they're all the same. So we would actually say they're jointly related to volume. Okay? Okay. So let me ask you a question. I would probably write down jointly. Do y'all see the example V equals I times R? Okay. In this case, I is on top, and ignore the R, and V is on top. Those two are what? Directly related. What about if I had the R or the I? R is on top and V is on top. They're also directly related. So V is jointly. Sometimes that word jointly is also a code word for guess what? Write that down on your paper. Jointly means directly. Jointly means directly. Okay? Jointly means directly. Now I want to talk about example 2. And I'm going to ask you to do 12 items. And they're not hard. Okay, number 2. I want you to hide the M for a minute. Ignore the M. Talk to me about F and A. F is on top and A is on top. So F is what? Write this down. F is directly related to what? A. Now, I want you to ignore the F and let's only look at M. Where's M located? On the bottom. So M is down. What's A? A is up. How is A and M? Inversely. So what I'm saying to you is A is directly related to M, or excuse me, to F, but A is what? Inversely related to M. So you can be both. That's what we call combined. You can actually have an and. There can be more than one letter. Okay. This is how I would describe 3. And I don't need you to write this down because I'm going to try to go to the homework. F is directly related to M and inversely related to V squared. Make sure you say V squared because you have to make sure you understand there could be a power. All right, here's all I want you to do. Find the page that has what looks like a bunch of pine trees at the top or whatever that are, the big silhouette at the top. Sorry. Okay, we're going to do these 12. It's not solving, it's just writing equations. This can be very easy. Okay. On the side of your paper at the top, jot this down. You ready? Put a bar. Anything that's on top will have the word what? It will have the word directly mentioned. If you put a part on the bottom, it would have what word? Inversely mentioned. When it comes to putting your constant K in an equation, constant K will always go on the top of a fraction. Let's do number 1. If it's the first thing I see, guess what the first letter is I write? V varies. I'm going to say V equals. Now remember, what was jointly a code word for? Directly. Let me give you a hint. Unless it expressly says inverse, you will not have a bar. Nope. There's no B and A. It's B and H side by side because there's no inverse. Every equation should have constant what? Constant K in it. So always put a constant K in the front. Okay, guess what the next one starts with? T varies. T equals, this time it says directly as W and inversely. Ding, 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 ding. If I see the word inversely, what do I need in my equation? W over N, you're right, I need a bar. And guess where constant K gets snuck in at? Constant K goes on top with whatever letter's up there. You see how quick these can be? I am going to ask you to do these 12 because they really aren't that bad. Let's try to squeeze number 3 in. P varies. Guess what I'll start with? P equals directly as the square of V inversely. So as soon as I see inversely, what do I need? There you go. V squared over R, and you're right, squeeze constant K on top. Everybody good? Yeah. Okay.